These are the guided notes for equivalent ratios. So the first thing we're going to do is to define what an equivalent ratio is. So an equivalent ratio are ratios that describe the same relationship. You can find equivalent ratios by multiplying or dividing each quantity in a ratio by the same number. So this is very similar to using our ratio tables, but now we just took the table away and we're using the same scale factor. So we have a couple practice problems. We have to write, basically they want us to write 2 equivalent ratios per problem here. So if I look at 3 to 20, I can pick any scale factor I want, as long as I use it with both the 3 and both the 20. So the first one I'm going to do is to multiply by 2. So 3 times 2 is 6, and 20 times 2 is 40. The next scale factor I'm going to pick is 3, so I'm going to do 3 times 3, which is 9, and then 20 times 3, which is 60. So 9 to 60. Okay, we have 5 to 6. So again, I'm just going to stick with multiplying by 2, multiplying by 3. So 5 times 2 is 10, and 6 times 2 is 12. Then I'm going to multiply both of these by 3, so 5 times 3 is 15, 2, 6 times 3, which is 18. Now we have 5 to 15. Again, I'm just going to stick with multiplying each by 2 and each by 3. So 5 times 2 is 10. 15 times 2 is 30. So 10 to 30. 5 times 3 is 15. 15 times 3 is 45. So 15 to 45. Okay, now I'm actually going to, when I get to 9 to 14, instead of multiplying by the scale factor, I'm going to first divide. So what I'm going to divide by is 3, because I know 3 is a factor of both 9 and 24. So 9 divided by 3 is 3, to 24 divided by 3, which is 8. Now I can take this rate or ratio, and I can now multiply it. I'm going to multiply it by 2. So 3 times 2 is 6. Over here times 2, 8 times 2 is 16. These are all equivalent, no matter if I divide or multiply. Okay, 10/20ths. I'm just going to split this in half. So again, I can do 10 divided by 2. 10 divided by 2, and I'm going to get 5. And 20 divided by 2 is 10. So we have 5/10. And again, I'm going to divide both of these by 2. Well, you know what? Let's not do that, because I can't divide 5 nicely by 2. So why don't we then multiply by 10? So on this side, I'm just going to write multiply by 10. 10 times 10 is 100, and 20 times 10 is 200. So 100 over 20. Okay, and then we have 18 of 30 seconds. So again, I'm going to divide both of these in half. 18 divided by 2 is 9. 32 divided by 2 is 16. 9/16. And then again, I'll just pick the same scale factors as I did on this one, multiply by 10. Remember, anything multiplied by 10, you just add that 0 to the end of that number. So 10 times 18 is 180. 32 times 10 is 320. Now these are all equivalent ratios, so think of these like fractions, like you read a fraction. If I wanted to simplify this, I would get to 9/16. Okay, similar to here, if I had 6 to 16 and wanted to simplify it, I would get 3 to 8. Those are all equivalent, they all describe the same relationship. Now if we go to number 4, you can solve real life problems using equivalent ratios. For example, Carol is mixing pink paint. The ratio of red to white paint is 2 to 1. If she uses 6 parts red paint, how much white paint does she need? So I'm going to set this up as 2 to 1. That's my original ratio. If I have 6 parts, and this is red, maybe I should put a label up here, so R for red, 2 white. If she uses 6 parts red, how much white paint does she need? So that's why here's blank. So I need to think, what do I do to get from 2 to 6? I multiply by 3. Whatever I do to one side, I have to do to the other. So 1 times 3 is 3. And I can't just leave it like that. I have to actually answer the question. So I have to say she needs 3 white paint. Okay, on the back you have some independent practice problems to do.